Hello everybody, I am Satyam. I welcome you all to my YouTube channel Learning with Satyam, and I do expect your positive engagement. Okay, so here we start. The topic of discussion is figure of merit, that is FOM. This figure of merit is a characteristic feature of a receiver in a communication system. So we will see where receiver lies and what is the communication system block diagram. So here is a communication system which comprises of a transmitter block, receiver blocks. Both are series of blocks actually connected together via a channel. So this is the communication channel, right? The same thing can be made like this also, where the channel is replaced by a summer block, and this channel, as I said, channel is affected by noise. So this summer block is getting one input from the transmitter, one input from the noise, right? And both are added together and coming to the receiver. So if transmitter output is alpha, noise is NT, so receiver input will be alpha plus NT. So here we have assumed noise is additive in nature. Okay, so that is why this is addition is here and summer block has been taken, right? So this alpha is the output of a transmitter, which is the modulated signal. So here I have made. So actually a message modulates the carrier. Carrier is the signal which takes the message over the large distances. So, and this is called modulation. So as a result of modulation, transmitter sends a modulated signal, alpha, that is mentioned here. So this alpha along with noise, these two comes at the input of receiver, and the receiver is supposed to give message back. So let's say my message is xt. So initially message is coming here. The same message has to come at the output of receiver. So from here to here. Okay. This FOM. Okay. So FOM is represented by gamma, which is given by signal to noise ratio at the output of receiver upon signal to noise ratio at the input of receiver. That is output signal power upon output noise power, that upon input signal power upon input noise power. That is why this figure of merit gamma is also called ratio of ratios, right? And this gamma is a characteristic feature of a receiver. So we will see what is S0, where it is positioned, all these four signals, right? So this capital S is signal power, capital N is noise power, I being input, O being output. So yes, here is a block diagram to show the positions of S0 and not Si and I. You see, this is a transmitter block which transmits a modulated signal. This is a channel which is given summer shape, right? So this channel has been represented by a adder, summer block, which takes another input from noise. So this NT, this noise is a wideband noise, right? Means over the frequency spectrum, the noise power spectral density is constant. So it is a wide Gaussian noise, right? So this is the power spectral density, and it is constant from minus infinity to infinity. That noise is constant. Okay, it is an ideal noise, right? So this is the noise NT. So both this and this modulated signal are fed to the receiver, where it comes in contact with bandpass filter first. So the first block of the receiver is the bandpass filter, which converts wideband noise NT into a narrowband signal, right? So the signal here, the noise at this point will be like given by this. Okay, so this is the power spectral density. So here it is, let's say this bandpass filter is center frequency is FC. So around plus minus FC. So this whole wideband signal will be converted into a narrowband signal, right? By narrowband means the bandwidth of this signal, that is equal to 2 FM. This 2 FM is very less than the carrier frequency. Okay, means FC is very higher than 2 FM. Right, in that case the signal is called narrowband. So this is the, let's say narrowband signal is SNIF. Right, so this is F. With respect to F, this is the power spectral intensity. Right, so this is the noise here, and the power of this noise is given by Ni. Okay, Si is the input signal power. So in the discussion, whenever we will talk about signal, we will ignore noise. Whenever we talk about noise, we will ignore signal. Okay, so Si and I are the signal powers at the input of the detector. Detector output powers are S0 and N0. Right, so this is the location of the powers S0 and N0, Si and I. Right, so this is FOM, SNR output upon SNR input. Right, so with this FOM, we can assess the noise performance of the receiver. Okay, so for a better system, better receiver, this gamma should be as high as possible. Right, so generally gamma should not be less than 1, definitely. So it is like this. It can be 1. Let's say it is gamma is equal to 1 for modulation systems like DSB-SC, like SSB-SC, right? Or in some cases it is like in AM also, whenever noise is less, then we can have gamma equal to 1 approximately. Actually, this AM signal under low noise condition, the gamma is given by x square t bar upon a square plus x square t bar. So this thing, that the numerator x square t bar is the mean square value of the message. So my message is xt, so xt squared average. So this is the mean squared value. Mean squared value of a signal is also called power. Right, so it is power of the message, PM. So this gamma can be given as PM upon a square plus PM. Okay, so this is the figure of merit of angle modulation system, that is phase modulation and the frequency modulation, wherein we see that the figure of merit of PM is equal to Kp squared into x square t bar. Gamma FM is equal to 3kf square upon omega m square into x square t bar. So this thing, these two, is called the mean squared value of xt. Right, so that we will see. So let us say this xt is my message. Okay, so what is the power of message? So the power of message xt will be given as mean squared value. Okay, means you take the square, take average, mean of it. So that will give you the power of the signal xt. Okay, so here let us consider the signal yt is given by a cos omega t. Okay, a is the angle, omega is the frequency. So what is mean squared value of yt? That is equal to y square t bar, which is given by a square into cos square omega t bar. Okay, cos square omega t, let's say cos square theta. So what is cos 2 theta? Cos 2 theta is equal to 2 cos square theta minus 1. So as a result we get cos square theta is equal to 1 plus cos 2 theta 1, 2. Right, so this value we have to put here. So what we get, mean square value, that is equal to a square upon 2 plus a square upon 2 into cos 2 theta. Okay, so yes, now the point here is the mean of a constant. So a square is a constant, amplitude 2 volt, 5 volt, 10 volt is a constant. So a square upon 2 is a constant, so constant mean is same value, right? And here it is cos 2 theta, so the mean of cosine signal over the average of cosine signal over a one complete time period, right? So that will be equal to 0. So here it is sinusoidal signal. Let's say, so this is equal to, this is t by 2. So from 0 to t by 2 it is positive, t by 2 to t it is negative. So over one time interval, the total average is, the average is 0, right? This is cosine 1, cos, that is equal to, it is going like this, means over one complete time period, that is equal to positive, positive here. So 1/4 it is positive, 1/4 it is positive, 1/2 it is negative. So like that. So over one time period it is 0. So this thing will be equal to 0 average. So the power of the signal, so this the power of this signal is given by a square upon 2, right? So this is the power of the signal. So yes, so these are the two, figure of merit for angle modulated systems. So here Kp denotes the phase sensitivity, Kf denotes the frequency sensitivity, okay? Omega m is the frequency of the message, and this is the power of the message signal, right? Mean square value. So after this we will see two questions, one question based on PM, one question based on FM. So here is the question. It says, take single tone message. Single tone message means the message is existing at one particular frequency, means my message is existing only at omega m frequency, okay? So this message MT phase modulates carrier. The carrier is given by a cos omega ct. So then we have to show the figure of merit for this phase modulation system is given by half of beta pm square. What is beta pm? Beta pm is the modulation index of PM signal, right? So that we will see. Okay, so to solve this question, we will start with what is the given information. The given information is that system is PM system. So for PM system, we know the figure of merit is given by Kp square into mean square value of the message. Okay, so here we will go step by step. So what is message? So this is the message. Mt is equal to Am cos omega Mt. Right. So here what we will do, we will multiply both sides with Kp. So here, so this is Kp Mt is equal to Kp Am cos omega Mt. Now we will take the power on both sides. Okay, so that is what? Mean square value on both sides. So what you will get? We will get this Kp square dot m square t bar, that is equal to Kp square into Am square upon 2. So for this we know from this, so this is Yt, a cos omega ct, a cos omega t. So what is the power? Power is given by a square upon 2. So similarly here, so Am cos omega Mt, what is the power? That is equal to Am square upon 2. So now let us put it here. So what is gamma Pm? Gamma Pm is equal to Kp square into Am square upon 2, right? Because gamma Pm is this, right? So, and what is the numerator? Numerator I can write it as Kp Am whole square. Kp Am whole square is nothing but, Kp Am is nothing but beta Pm. So what is beta Pm here? That is modulation index for PM system. That is equal to mod of Kp Mt. That is Kp is a constant. So what is the dot multiplied by maximum of Mt. So what is the maximum of Mt? Am, right? So Kp Am is nothing but the modulation index of PM system. So this is another question wherein we can see this question is also regarding single tone modulation, means my message is existing only at one particular frequency. So this is my message signal represented by Am cos omega Mt. So it is existing at frequency omega m, and so it is a phase, it is a frequency modulation system. I forgot to write. So this message frequency modulates this carrier. Carrier is given as the same, a cos omega ct. So what he is asking is, what is the figure of merit of FM system? That is equal to 3 upon 2, that is 1.5 beta FM whole square, beta FM square, right? So 3 beta square upon 2. So that we have to prove. So let us see. So yes, so this is the solution. Since FM system has been given, therefore figure of merit is gamma FM. which is given by 3 kf square upon omega m square into x square t bar. Okay, so what is this? This is the message signal power, which is, and what is the message here? Message is am cos omega mt, right? So so this can be written as am square upon 2, which gives me 3 by 2 into beta fm square. So it is very easy, but we should know what is beta fm. Beta fm is the modulation index of fm signal, which is given by delta omega upon omega m. Omega m is the message frequency, modulating signal frequency, and delta omega is the frequency deviation, where delta omega is given as kf into mt mod, means the maxima of kf mt. Kf is a constant, that is frequency sensitivity, and mt here, the mt is this. What is the mod of this? Mod will be am, right? So here this beta fm is equal to kf am upon omega m. So kf am upon omega m whole square, that is equal to beta square, and hence the answer. Okay, thank you very much.